Good morning, ladies and gentlemen. Welcome aboard PME flight 210401 from Taipei to Costa Rica. Our flight will take 6 minutes. We hope you enjoy the flight. Thank you.
Wind is the most important part of the airplane. It plays important roles when flying and taking off. Let's first talk about some fluid mechanics phenomena when the airplane takes off. Lift. We can use balloon equation to explain the lift of the airplane. Winds will produce lift when the airplane takes off. Pressure difference is the reason why lift arises. The shape of the wing is smooth on the one side and relatively large curvature on the other. The velocity will increase on the smooth side and the pressure will decrease. This causes the pressure difference that lifts the airplane takes off. Resistance. Resistance force can divide it into two parts, induced force and parasite force. Induced force is the force that arises with lift. Parasite force is the force positively related to the velocity of the airplane. The faster the airplane flies, the smaller the induced force. In other words, to fix the lift to support the weight of the airplane, the lift coefficient should decrease when the velocity of the airplane increases. Aircraft turn in the air by controlling flight control surfaces and power control systems. Here's how a typical commercial aircraft accomplishes turns. Rudder. The rudder can be deflected left or right. When the pilots operate the rudder, it changes the aircraft's heading. By increasing the rudder's deflection angle, the aircraft generates yawing force, causing it to turn left or right. Ailerons. When the pilots operate the ailerons, one aileron moves downward and the lift on the one side decreases, causing the wingtip to lower and the aircraft to roll in the opposite direction. This roll generates centripetal force, resulting in the aircraft's turn. For example, to make a right turn, the pilots will deflect the rudder to the right when simultaneously lower the left ailerons and raising the right ailerons. This combination changes the aircraft's deflection bank angle, resulting in the desired turn.
Ladies and gentlemen, the captain has turned on the fasten seatbelt sign. We are now crossing a zone of turbulence. Please return to your seat and keep your seatbelt fastened. Thank you.
Have you experienced this kind of situation? Let us find out what is turbulence. Turbulence is a state of fluid motion characterized by chaotic and irregular fluctuations. In contrast to turbulent flow, there is another type of flow called laminar flow. Laminar flow is characterized by smooth layers in the direction of flow with minimal interaction between the layers. When the flow velocity becomes high enough that the flow lines becomes indistinguishable, small vortices form due to various collisions, and this is what we commonly refer to as turbulence. We can classify turbulence in the atmosphere into two types, convective turbulence and clear-in turbulence. The more dangerous is the clear-in turbulence. Clear-in turbulence occurs mostly in the higher regions of the troposphere, typically between altitude of 7,000 to 12,000 meters. It's generated when air masses of different velocities intersect, without any involvement of water vapor. Consequently, it can be observed or detected. Therefore, when an aircraft encounters this type of turbulence, it's the most dangerous and can potentially lead to situations like loss of control. What we want to mention next is supersonic flight. Supersonic flight is a situation where the speed of aircraft exceeds the speed of sound during flight. Then let's briefly discuss the relevant knowledge about supersonic aircraft and fluid mechanics. The shock wave. When the speed of aircraft exceeds the speed of sound, the fluid close to the disturbance cannot respond in time before the disturbance arrives, and the shock waves will be formed. Shock waves are a form of turbulent propagation and are also pressure waves that arise in fluid surrounding an aircraft. Shock waves form on the front of fuselage and other sharp edges as the plane passes through the air. These shock waves cause a sudden change in pressure, which can cause a loss of total pressure and thus a sonic boom. Let's sum it up for difference between subsonic and supersonic flow. At subsonic speed, the pressure fluctuation can be transmitted from the back of the flow field to the front, while at supersonic speed, because the gas disturbance can no longer propagate upstream, the pressure fluctuation can be transmitted to the upstream, and the pressure in the subsequent time will be different from the existing. The pressure waves are superimposed on each other. In this way, the change of fluid properties is compressed in a very small range, which forms a so-called shock wave. Next comes the landing process of the plane. It needs flaps and spoilers to help. The flaps will be extended downwards to increase resistance. After the spoilers is fully opened, the airflow blows into it and forms the maximum air resistance, ensuring that the aircraft has enough lift at low speed, preventing the aircraft from hitting the ground all at once. Regarding the change of the flow fields caused by spoiler at different angles, we can observe this situation through the flow visualization experiment we did this semester. When angle is 0, the flow field near the wing is very smooth and close to the wing. When angle is increased, the flow is hindered by the spoiler, causing turbulent flow near the wing. When the angle is larger, its position will be closer to the spoiler's front end. Because the force acting on the wings cannot stop the aircraft in a short time, the reverse thrusters will be released after the aircraft touches down. It reverses the backward airflow to the sides for rapid deceleration. At the same time, the aircraft will also use the brakes of the wheels to slow down.
Ladies and gentlemen, welcome to airport. Gamsha Liai. Have a nice day.